question.
1 second, sir. Design a 2 to 4 line decoder with only NAND gate, include an enable input.
Yes, tell me now, what is the problem?
Sir,
What problem you are getting?
so what is the meaning of enable input here? I can
Only one.
create.
Only one.
Okay.
Generally, what happens when you are using the encoder and decoder, only one enable input is sufficient.
Okay.
You can consider one enable input, and suppose what happens when enable input pass one, that time what happens, that particular encoder is active. If it is pass 0, that time what happens, it is deactive. Suppose I am using, as an input I am providing 0, and when we are connecting the enable input, that time what happens, I am using the NOT gate. Okay, so initially input is 0, and when it is facing the NOT gate, then automatically it is converted to 1. So that means what? Ultimately one signal is passing. And if you are not using any NOT gate, that time what happens, simply you can pass the input as a 0, and when passing the 0, that time all the inputs are deactive, and when it is passed 1, then time what happens, some particular input are active. Are you getting my point?
Yes, sir.
So what happens? For that particular purpose, what happens? So if it is E is 1, and if you are using the NOT gate, that time what happens, all the encoders are deactive. Then you can in the truth table you can use the don't care term.
Yes, sir. Yes, I got it.
It is maybe it is does not affect if it is 0 or 1, because enable is 0. Are you getting my point?
I got it. Yes, sir.
And when E equal to 1, that time what happens, according to the encoder properties, you can fill the lines or values. Okay, binary values. So
Okay,
this particular part is very important. So whatever I am providing, I am just giving the sample question. So I am providing the homework. But remember one thing, that particular homework is not sufficient for you. You can do practice more from the textbook. And till now, no one can ask me, sir, I am doing from this particular book and I am facing some particular problem. You never ask that type of question. So solve or unsolved problem, you can take from the Maurice Meno book also. It is the standard book. You can do the practice. It is not like that you can always try for the solvable problem. Unsolved problem, at the end of the chapter, some particular questions are there. You can solve that particular question. Otherwise, what happens? Some doubts are not clear. Okay, and in the class timing, it is not it is not possible for me. I am discussing all the problem. So I am taking 1 or 2 example or 3 example. After that, what happen? I am giving some particular homework. So it is your duty. Sincerely, you can complete that particular homework. Otherwise, what happen? Some particular problem you feel okay, but when the problem is coming some critical manner, the same something not no direct questions are coming. Suppose I'm not asking the design, I'm asking some different type of part, but that particular logic is, suppose it is related with encoder. So what happen, due to limited number of your practice, it is very complex for you. That particular problem is complex for you. Are you getting my point?
yes, sir.
Yes. Okay. No,
Yes,
I'm not asking Depository Sharma. I'm asking. I'm providing this particular information to all the students, and he's asking have some doubt. It is very good. I'm appreciating. But other people, why I don't know why they are very silent. If you are not getting any problem, then it is okay. Tamalikara, your microphone is off. Sorry, your microphone is on. So can you say something?
Yes, sir. Sir, I have a doubt in question number 1. Design a BCD to 7 segment decoder. So the doubt that I am facing is what is meant by a 7 segment decoder?
So the last class I am providing some particular hints. So 7 segment decoder means what? Suppose you can consider one particular digital clock. Okay. Yes, yeah, you can on your microphone. It is better. Uh, Seven segment means what? Suppose you are considering one particular digital clock and the numbers are showing in digital form. So what happen when we are suppose it is some lines are vertical line and some particular lines are perpendicular line. If you just you imagine, okay, and when you are counting that time what happen? Always how many numbers of lines are there? 1, 2, 3, 4, 5, 6. I think 6 lines are there. 1, 2, 3, 4, 5, 6. Sorry, 7 lines are there. Okay.
Okay.
Okay, just wait for a few minutes. I'm going to the present. Some particular screen I am presenting my entire screen. Then it is clear for you. Okay. Suppose I am considering something. So see here, if I'm using this particular way, this is this one, okay.
Yes.
After that, I'm using this one. After that, I'm using this one. Suppose this way. Some particular gaps are there in between. Suppose okay. So this way, just you. I'm considering this way. Suppose I'm considering this way. Okay. Again, I'm considering this way. And lastly, suppose I am adding here this way. The figure is not up to the mark. Just for your understanding purpose, you can design something else. So now you tell me. So how many lines are there? 1, 2, 3, 4, 5, 6, 7, 8. Yes or no? So here, how many lines are there? It is the 8 lines.
1 2 3 4 5 6 7
Okay, it is the just a minute.
7 line.
Yes, this one is the one line. 1, 1, 2, 3, 4, 5, 6, and 7. So it is called a 7 segment. So all the lines have some particular segments are there. So it is name is 7 segment. Now why we are using the BCD? Because what happened? We are concentrated. BCD means what? What is the properties of BCD? BCD range is 0 to 9. You remember? I think. Okay.
Yes.
So that means what happened if we are considering from 0 to the 9, that time what happened, any particular digits we can from. We can from 11 also, we can from 99 also, any digit. Okay. So what happened, why we are using the decoder actually here? Because see here, if we are presenting the 7, number 7, okay, that time what happened, these particular lines are active, these particular lines are active, and these particular lines are active, like this way, 7. Okay, and all other lines are deactive. That means what? So when we are providing the when you are constructing the decoder, all the lines you are putting as a 0, and these particular parts are active. These particular lines are active. You can design the decoder such that these particular lines are active. And suppose what happen when you are constructing for 0, that time what happen, this particular line is active and this particular line is active. This particular line is active, but this particular line is not active. That means what? It is representing as a 0. Okay, this way you can construct the truth table at first, behavior of this particular. So it is name is 7 segment BCD. 7 means what? All the when all the segments are active, that means what happened? Total number of segment is 7. And why we are calling BCD? Because we can represent from 0 to 9. Okay. Now, how we can construct this particular problem? How we can construct with the help of decoder? Okay, so that means what? At first, what happen? You can draw the truth table, and you can provide some input such that one time it is zero is occurred. When zero is occurred, which particular lines are active when the number is zero? When number is 5, then which particular lines are active and which particular lines are deactive? When deactive, you know what we will do? We will put as a 0. And when it is 1, that time when that particular line is active. Okay. And after that, when we are designing now, when you are constructing the truth table, then you can easily design the circuit based on the. You can use NAND gate also. You can use OR gate also. Okay.
Okay, sir. Thank you,
Okay.
sir.
Now are you getting?
Yes, sir. Thank you. Sir.
Okay. Okay. Any other doubt? Any other doubt? Okay, then I will start my class. Okay, so this is the lecture 9 and 19, and we are discussing the combinational circuit. Last class we are discussing the encoder. Okay, so encoder means what? It is the reverse operation of decoder. Are you remember? And you know how we are designing the decoder and decoder. So decoder and encoder, they are reverse operation with each other. And okay, so just you remember how we can implement that means, and the procedure is same. That means at first when we can design the behavior of the particular problem with the help of truth table. After that we can construct the circuit. Okay, so that means what? When we are talking about the decimal to BCD encoder, that time how many inputs are there? Input is D0 to D9, and when we are converting to the BCD, that time only four lines are there. Okay, that means what? This one is how we can represent it. This one is this one we are representing. This one is we are representing what? These are we are representing as a BCD to decimal to BCD encoder. Okay. Some particular problems are there. 2 to 4 line decoder. That means 2 line, and 2 to the power 2 means what? It is 4. So when we are using other lines, that time what happen? We are using 16 into 4 decoder. That means what? 2 to the power 4 into 4 outputs. So when we are talking about the BCD, that means you remember up to 9 range from 10 to 15 is a don't care. I think you remember that particular part. Okay, but what happen? The generating output is 4. So this way we can construct decoder and encoder. Okay, now see here, when we are using the encoder, you remember the input lines, only one particular input lines are active. In this particular table, see here, the number of input lines are 8. Okay, that means what? How many outputs are generated? 2 to the power 3 equal to 8, 3 outputs are generated. That means F2, F1 and F0. Okay, now what happened? Based on the properties of encoder, that means only one particular input lines are active, and based on that we are taking some output binary sequence. So in this particular table, see here, so 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 when we are using when D0 is active, what is the binary sequence? Binary sequence is 000. When D1 is active, don't right now you don't consider this particular cross symbol. Okay, so I'm just normally saying that about the what is the how encoder is actually works. Okay, so when D1 is 1, that time what happen? All the binary sequence of outputs are this particular form. That means what? 001. When 001, that time what when D1 is active. When all the outputs are 0, that time what when D0 is active. This way we are going. Okay. Now then, why priority encoder concept is coming? Priority encoder concept is coming only for this particular reason. Is that sometimes what happen, we can violate some particular faulty region or false situation what happen, at a time 2 lines are active, suppose. But based on the properties of encoder, only one input line is active at a time. Okay. Suppose what happen, this one, D1, suppose here instead of 0, suppose this one is 1 and this one is 1. Okay. That time what happen, when now what happen, there are 2 lines are candidate to go through the output. That means we are generating the output, but it is not possible because what happen, we can violate our encoder properties. So how we can exactly identify which particular line is actual input for that particular output. So based on that, this particular priority encoder is generated. Now see here, we are giving some priority to the input lines. Suppose in this particular problem, see here, when 2 inputs lines Di and Dj. Okay, suppose what happen, we are assuming that I is greater than J, and what happen, request service simultaneously, or Di and Dj is both are active, suppose 1 1. Okay, that time what happen, based on this priority, Di is assumed to have a higher priority of line Dj. Okay, so priority line, sorry, here you can write line then Dj. So Di is assumed to be a higher priority line as compared to or than Dj. Okay, and based on that, we are generating the output. That means output of the encoder gives the binary code indicating which input lines requesting service has the highest priority. So how we can constructing this particular table, see here, this one is 1, when D0 is 1, suppose what happen, here is a no problem, all are 0, here it is 1. So what happen, the initial number is 1, so automatically what happen, only one candidate is are there, and that time what happen, it is generating as a dipole 0. But when we are going to the second line, that time what happen, D1 is one particular candidate is there. Okay, so what happen, this particular D1 is the highest priority than D0. So cross means what? It may be, don't care, that means it may be 0 or it may be 1. It is does not matter for us, but the always highest priority for D1. Are you getting my point? So this way, this one is 1, that time what happen, D1 may be 0 or maybe 1. If it is 1, then also we can consider highest priority 1 for D2. And here if D0 is 1, that time also we can consider the highest priority of 1 for D2. This way we are going. See. So that means what? We are, if both 2 or 3 lines are active, but based on the some priority, we can select that particular input line. That is the main objective of the priority encoder. And if you are carefully check this particular expression, see here, when we are considering, I am showing only one. You can generate from your side for F1 and F0. So you can just look very carefully how I am generating for F2. F2, see here, F2 means this one is 1. Okay, and D4 is 1. That means D4 line is active. So here I am writing D4. And all other remaining lines are, that means what? All are 0, 0. So here I am writing D5, D6, D7. And this particular part does not matter for us because this one is the lower priority. Are you getting my point? Again, what happened? Next one is 1. So 1 means what? D5 is active. So I am writing in the soft form. And D6 and D7, this one is the D6 and D7. So it is the complement form. Complement form means what? It is 0, 0 in soft form, sum of product. Other parts are don't care. That means it is the lowest priority than D5. This way we can write for this one also and this one also. So ultimately what happens when we are implementing this one, only these particular parts are remaining, equal D4 plus D5 plus D6, D7. So you can write for F1 also here, F0 also. It is similar manner you can easily write for F1 and F0 also. Any doubt this one?
No, sir.
Okay, all of you getting?
Yes, sir.
All of you?
Yes, sir.
Okay. So this is called a priority encoder, and the block diagram of priority encoder are same. We can also use the enable input, and the input properties and output properties are same. But when you are writing the block diagram above, if you are using the priority encoder, that time what happen? You can just write here you can just write here. This way you can design. Just you can write here priority encoder. Just you can write here priority. PRIOR, priority. You can write very clearly here so that people can automatically understand this one is the priority encoder. Priority encoder. Suppose what happened here? Suppose 8 into 3. 8 into 3 encoder. Okay, here you can write encoder. This is the block diagram, not a logic diagram, remember. Encoder, you can write this way. Okay, you can write an encoder. So what happened here, you can use this one is D0 and up to, you can write up to, you can write D7. Because we are starting from 0. So total number of input lines are 8. And this one is the output line, F2. Or you can write F0 here, F0, F1, and this one is F2. This way you can write, and you can use here enable input, it is no problem. If you are using here not gate, here that time what happen? When you are supplying 0, here suppose I am inserting as a 0, that time what happen? This particular decoder is active due to not gate. If you are not using any not gate, that time what happen? 1 means for it is active and 0 means it is deactive. It is very simple. Next is what? Comparator. So comparator is also one type of logic circuit, or you can say the combination circuit. And why we are using the comparator? Because what happen? We can compare the magnitude. We can compare the magnitude of two binary numbers. Okay, it is maybe a sequence of binary numbers. Okay, suppose okay, no problem. Suppose what happen when we are using the comparator? Three particular categories. Actually, we are defining the comparator. EQ is what? It is equal. GT means what? Greater than. And LT means lesser than. If EQ equal to 1, that time what happen? We can, oh, sorry, here some particular mistake. Here it is greater than, and here it is equal. Okay, sorry, just you correct this one. Okay, so EQ equal to 1, that means what? This particular one is only occurs when if and only if A equal to B. When GT equal to 1, when if and only if A greater than B. And LT equal to 1, when if and only if A less than B. Okay, and always remember when we are using the comparator, that time what happen? We can use the on-site gate, or you can say the XNOR gate. Now, why we are using the XNOR gate? So you can remember the behavior of the XNOR gate. If it is 0 0, both inputs are 0 0, that time what happen? This one is 1, and when both the inputs are 1 1, then also the output is also 1. So that means what? When these two are equal, that time what happen? The gate is active. This one is also 1 1, that means equal. This particular one is also equal to this one. Okay, due to that particular reason, the output is always 1. So always remember when we are using the comparator, that time what happen? Based on this particular properties, we are using the XNOR gate. People are asking why we are using the XOR gate, why we are not using the NAND gate? Because what happen? The for comparing purpose, XNOR gate, it is suitable due to this reason. Okay, operation of the XNOR gate. Okay, suppose how we can perform the comparator? It is very simple. See here. Suppose I'm using the 4-bit binary numbers. Suppose this one we can consider as A equal to what happen? A equal to A3, A2, A1, A0, and B equal to, suppose B equal to here B3, B2, B1, B0. So how many numbers are there? Binary numbers, 4-bit binary numbers are there. Okay, and if because we cannot compare A3 with B2, we can compare the position of the bits. Okay, we can always compare A3 with B3. We can compare always A2 with B2. We can compare A1 with B1 and A0 with B0. If A3 equal to B3 or A2 equal to B2 or A1 equal to B1 or A0 equal to B0, that time what happen? If these particular conditions are satisfied, that time what happen? We can write this way: EQ equal to this. So what happen? Here we are using the XNOR operation. That means what? If it is A3 equal to 0, then B3 also 0. Or you can write this way also. If this one is 1, that time what happen? This one is also 1. And similarly, A2 is 0, then also B2 is 0. A2 is 1, then also B2 is 1. So it is the equality properties of compared. Okay. So this one we can solve. And if when we are getting this particular expression, then you can easily draw the logic circuit. How many inputs you are considering? 4 inputs: A1, A2, A0, A1, A2, and A3. Then you can based on the operation you can apply the gate. Here you can use the XNOR gate. Suppose A greater than B. A greater than B. B means what? Suppose I'm writing here. Suppose I'm writing here A3. A3. Suppose here A3 is 0, 1, 0, and 0. Suppose B3 is it is not a A3. It is A. This one is A, and this one is B. Only B. So this one is what I am writing here: 0. Okay, 0, 1, 1. Okay, we can compare the magnitude of two numbers. So here A and B, and suppose this one is A3, this one is A3, this one is A2, this one is A0, something like that, and this one is B3, B2, B1, B0. So when we are comparing the most significant bit, that time what happen? Both are 0, 0. That means what? They are equal. Okay, most significant bits are equal. So when we are going shifted to the right, that time what happens? See here, the second bit, the next most significant bit. That means when we are going from left to right, that time what happen? A equal to 1 and B equal to 0. That means what? Obviously what happen? A is greater than B. So without checking this one, automatically we know that A is greater than B. A is greater than B. Okay. So when A is greater than B, that time what happen? This particular expression is satisfied. How? One particular condition is that the most significant bit is the second bit is 0. If B3 is equal to 0 and A3 equal to 1, that time what happen? This particular condition is full. A3 B3 dash. That means B3 complement. So complement means what? It is 0 and A3 is 1. So no need to check this one. It is automatically covered. From that, this one we can automatically know that A greater than B. Suppose A3 and B3. Suppose this particular condition, A3 and B3 are same. Then what happen? We can just put the XNOR gate here. That means what? A3 and B3 are same. But what about the others? Yes, B2 A2 is not equal with B2. A2 is not equal with B2. Okay, because A2 is here 1 and here it is 0. So that time what happened? Here I am writing A2 dash with B2. B2 complement means what? It is 0 and this one is A2. And also this particular condition is not satisfied, then what happened? Obviously A2 equal to B2. And always A3, yes, that means A2 equal to B2 and A3. That means A3 equal to B3 and A2 equal to B2. That time what happened? Maybe the next most significant bit is lesser than A1. So here I am writing here complement. This one is also false. That time what happened? We are writing A3 equal to B3, A2 equal to B2, A1 equal to B2. That time what happen? Last bit, that means least significant bits, A0 is 1 and B0 is 0. So if this particular all the conditions are satisfied, then we can say that A greater than equal to. And just reverse order. So that means what? We can consider B greater than A. That time what happen? Instead of complement with B, we can apply the complement with A. See here, all are complement from. Here all are complement from. Okay. So this way we can use the comparator. Any doubt this one?
No,
Any
sir.
doubt?
Yes, sir.
Anything? All are. You have any doubt? Then please ask me. सबको समझ में आ रहा है?
हाँ sir.
Okay. So based on this particular expression, you can easily design the logic circuit. It is no problem. Okay. Now we can directly go to the multiplexer, or sometimes it is called a data selectors. Okay. So multiplexer means what? A multiplexer means transmitting a large number of information over a small number of channels or lines. So that means what? Always you remember, when we are constructing the multiplexer, the output is always 1. Generally we are using always output is 1. Okay. And digital multiplexer is combinational circuit that selects binary information from one many input lines and direct to a single output. That means what? Here this one is the single output, and this one is the input. Okay. So what happens? Some particular lines are propagated to this particular output, or maybe propagated to this one, but not at a time. Only one input line is propagated to the output. If this one is considered, then we cannot use this one. If we are using this one, that time we cannot use this one. Are you getting my point? So what happened? So how we know which particular input lines is propagated to the output? That particular part depend on the select line. Based on the select line, we can propagate some particular input line to the output line. Now, what is the construction criteria of multiplexer? So generally we are using 2 to the power n input lines and n selection lines. I am not talking about the output, because what happen? Output is single output. Okay, that means what? In this particular case, what happen? 2 inputs are there, and if we are writing in this particular fashion, that time what happen? What is the output? Output is 2. And if we are breaking this particular part in the form of this one, that time what happen? N equal to what? N equal to 1. That time what happen? Only one particular selection line is required for 2 into 1 marks. And shortly I am here multiplexer also short from is marks. Okay. So how many selection line we are using for 2 input lines? Only one particular selection line we are using, because 2 to the power 1 and n equal to here 1. But when we are using 4 into 1 multiplexer, that time what happen? 2 to the power 2. How many selection line we are using? Only 2 selection lines. Okay. Now see how this particular multiplexer actually works. Okay. So we can just arranging in this particular fashion. Suppose, or otherwise you can use here, this one is the selection line, this one is the D1. So sequences does not matter, you can write any form. So but always you can write in the selection line as D1 and D0. So D1 and D0s are input lines, and S is the selection line. And what is the output? I am here, it is not F, suppose it is not Y, suppose according to truth table I am using F, so it is F. Okay. So when we are writing 2 to the power 3 means how many outputs are generated? How many binary sequence are generated? 8. It is 0 to 7. Okay, 0 to 7. So here I am writing this one is the 0 and last one is 7. Okay. So when s equal to 0, that time what happen? When s value is 0, that time d1 is propagated to y. And when s equal to 1, d0 is propagated to y. Same thing see here. So when s equal to 0, what is the value of d1? Sorry, here some particular problem. Suppose here, sorry, here I'm writing this one is d0 and this one is d1. Then it is clear. So when s equal to 0, that time whatever the value of d0, it is propagated to the output. See here, this s equal to 0, this s equal to 0, this s equal to 0, this s equal to 0. And what is the value of d0? D0 is 0, 1, 0, 1. So same value appeared in f. This one is also 0, 1, 0, 1. But when s equal to 1, that time when d1 is propagated to y. So see here, all the s are 1. Okay. For that particular purpose, what is the value of d1? D1 value is 0, 0, 1, 1. So this particular value is propagated to the f. So see here, this one is also same. Are you getting my point?
Yes, sir.
So this way we can design the multiplexer, but there are different type of concepts are there in multiplexer. That particular part we'll discuss later. Just you know the basic construction of multiplexer, how the multiplexer actually work. Now when we are going to the implement the 4 into 1 multiplexer, so what happen 2 to the power 2, 2 to the power 2 to the power 2, so 2 to the power 2 equal to 4. So n equal to here 2. Okay. For that particular purpose, we are using two selection line. This one is called a selection line, and this one is called a data lines or input lines. And you know, a multiplexer always produce the only one output. Okay, suppose. Okay, so see here. Here we are using how many inputs? Now, how many total when we are forming the table? That time, whatever, how many variables we are using? We are using S1, S0, D0, D1, D2, D3. So how many variables are there? 6 variables are there. Okay, and 2 to the power 6 means what? We can constructing the truth table based on 2 to the power 6. It is very huge. 64, that means rows we are considering. Okay, and after it we can put the binary sequence. So it is very huge. So what happen based on the properties of multiplexer, we can construct very small truth table also. So how we can construct this particular truth table, you can carefully check. Okay, how we can construct this particular truth table. So what when obviously we are using all the selection line is S1, S0 and input lines are D0 to D3 and this one is the output. F is the output. Okay. So what when see here all two binary sequence we are providing. This one is the 0, 0. All the combinations we are using because what when one binary sequence it may be 0 or it may be 1. So what when for a particular purpose we are considering all the two binary sequence from. So first one is we can write all the possibilities. The first one is 0, 0. If we are using only two selection line. Second one is it may be 0, 1. 0, 1, 1 4 0 and 1 4 1. So here I am using only two. And this one is the 1 0. So it may be 1 4 0 and 1 4 1. And last one is 1 1. It's very simple. Okay. So when S0 S1 equal to 0 0, so D0 line is propagated to Y. See here, this one is 0 0. That time what is the value of D0? D0 value is 0 and 1. So same value is appear to the output. and rest of all are don't cares. It is not required for us. Okay. Next, see here D1. D1 means what? 1 is maybe S1 is 0. That means S0 is 0. Sorry, S1 is 0 and S0 is 1. So that means what? This one is 0, 1. So when S1 is 0 and S1 is 0, yes, S1 is 0 and S0 is 1, that time what happened? D2 is propagated to Y. Okay, for that particular purpose, what happened? This one is, see here, 0, 1 is active based on this particular binary sequence. Okay, so all other cells we can put as a don't care. And this particular 0, 1 is propagated to the output. Next thing is what? D2 is 0, 1. So when S1 is 1 and S0 is 0, that time what happened? D1, sorry, I am writing D0. So you can write here D0 also. You can write any form, no problem. I am writing here D3. And this particular, suppose I am considering this particular line is propagated. So what is the value of D1? Here D1 value is, D2 value is 0, 1. Okay, D2 value is 0, 1. So here we can put here 0, 1. So last, this one is, suppose we can consider this one is 3. This I am writing. You can know it is, the sequence is not important. You can consider D1 and D0. So D3 means what? When S0 and S1 are 1, 1. Both are 1. Okay. That time what happened? D3 is propagated to Y. So here this one is 0, 1. And when 0, 1 is occurred, when S1 is 1 and S0 is 1. When S1 is 1, 1. So what happens? Same value is occurred here 0. So it is very easy. Right? When you are designing the truth table for multiplexer, it is very easy. You can just maintain the properties of multiplexer. Okay, properties means what? Always input lines depend on the selection line, and that particular input lines goes to the output line. Okay, and output line of multiplexer is always only one output is generated. That means what? If I am writing 8 into 1, I am writing 8 into 1 multiplexer. That time what happened? 8 input lines are there. And how many selection lines? The selection line is 3. Because 2 to the power 3 means what? It is 8. Suppose I am writing here 8 into 1 marks. 1 marks. So always produce only one particular output. That is F. And how many inputs are there? Suppose this one is S0. This one is S1. And this one is S2. And input line is D0 to D7. This is the 8 into 1 marks. Okay. Lot of problems are related with the multiplexer. Okay, that particular part we will discuss later. Okay, so how we are designing 8 into 1 marks with the help of 4 into 1 marks, and suppose some particular mean terms are there. From the mean terms, how we can construct the marks. Okay, and what are the criteria? Suppose for even here we are using only 3 variables, but mean term is more than 3 variables. Then how we can use the multiplexer? How we can construct the multiplexer? So that particular part we will discuss later. Okay. Today is what? सो रहे हैं क्या सब लोग?
Sir, Saturday, 7 on.
7. So when is my next class? Tuesday, next Tuesday means what? Tuesday is 10. Okay. So when is your second internal exam?
11, sir.
11.
11. Okay. So don't ask me the syllabus. And if you are excluding the syllabus of first internal exam, whatever we have learned and whatever we are discussing, all the topics are included in the second internal exam. Are you getting my point? Okay. Any doubt? Any doubt? You can say something.
No, sir.
Okay. So 11 is Wednesday or Tuesday?
Wednesday, sir.
Wednesday. And Tuesday I will take the class, no problem. As usual, I'm taking the class, and you are getting the instruction manual. Okay, I'm sending through WhatsApp, and otherwise I'm sending to the class representative, and he will share the WhatsApp on WhatsApp. Okay, and I'm providing the link before 2 days or 1 days ago, and on that particular time you can activate that particular link and you can give the exam. But remember, don't forget to submit the button after completing all the part. And this is also optional type question, because descriptive have a problem, some particular problem I am facing. So again, I am conducting the optional question. Okay, when we are providing all the options for all the questions, the lastly what happen, you can please click the submit button. And suppose what happen, the closing time is 11 a.m. then don't go to the last moment. Otherwise what happen, maybe some particular problems are coming, you cannot submit, and your entire, so before 10:55 or 10:56 and for 10:57 you can submit the answers, all the options, or submit the form. Are you getting my point?
Yes, sir.
Yes, sir.
Okay, today I am feeling very laziness, so I am not today I am closing here. And after that what happen, most probably your combinational circuit chapter is almost complete. Okay, and better you can go for the syllabus, whatever I am providing, and you can find out any other topics are left in the combinational circuit, then you can please inform me. But don't threshold gate on threshold, that is something different topic, so don't include with the combinational circuit. That particular part we will discuss later. Okay, and if any parts are remaining left, then that time whatever you can just inform me, sir, this particular part, and you can check the syllabus. But multiplexer is not completed till now, and there are different type of examples we will discuss later. Okay, and when this particular combinational circuit is over, we are going to some particular threshold gates and threshold value, and how we can design the threshold gates. Okay, some what are the criteria, and what is the method we have to follow when we are designing the threshold gates. Okay, that particular part we will discuss later, and after that directly we are going to the sequential circuit. Okay, and I don't know, most probably Jagannath sir contact with you, so you can carefully study that particular video. Okay, you can and after that what happen, just you can try from your side one or more times, so that when we are starting our lab class, that time what happen, you feel comfortable. Are you getting my point?
Yes, sir.
Yes, sir.
So whatever till now we are discussing, suppose we are demonstrating 2 and 3 examples how we are designing the gate. Suppose XOR gate, NOT gate, with the help of some particular programming language. You can use the Verilog or VHDL. It is no problem. But that particular tool supported some particular Xilinx type of Xilinx is a very big software. So that particular tool also, but that particular tool required enough space, more space. Okay, so sometimes what happen, you can install in your machine, after that you can try, then that time what happen, some particular problems are coming. Okay, but anyhow, Jagannath sir, whatever he is giving the instruction, you can follow that way also. Okay, it is no problem. Most probably lab class will start from Monday. You can check the timetable. From Monday we will start. Okay. Otherwise, what happen? We can taking some more times. If you are familiar with some particular programming, then we will give some particular providing some particular experiment. Then you can do yourself. And when the lab class will be conducted, just you demonstrate. And if there is some particular fault are occurred, then we will discuss. Are you getting my point?
Yes, sir.
Okay. Then thank you very much. Okay, just a minute. Okay, you leave one by one.